Hey guys, welcome to day 6 of programming every day until Codeforces GM. I guess today we're going to start with this problem here. 455A, boredom, a 1500 rated question. I already started on it, but I was like, it's already 9:30 a.m. Might as well start my recording. Yeah, I mean, I have a solution that works, but the problem with it is it runs into this runtime error, and after asking some of my friends, apparently there's like a recursion limit which causes like a stack overflow or something. So uh yeah, basically the consensus was don't use recursion in competitive programming, and anything recursive can be written iteratively. So we're going to start off by writing this iteratively. I guess I can explain what this code does so far. Okay, let's talk about this question first. Basically, you're given an array, and you're allowed to pick anything in the array. But the problem with okay, so you pick an element in the array, and then you have to remove everything that's one greater or one less than that element from the array, and you get that many points. You get the value of the element you picked as points. So I'm not explaining this very well. Let's just look at this note here. Basically, so we pick 2, so you get 2 points, and then you have to remove all the values of the number you picked plus 1 and the number you picked minus 1 from the array. So that would be 2 plus 1 is 3. We would remove all the 3's, and then 2 minus 1 is 1, so we'd remove all the 1's. So now we're just left with like this array here, 4 2's, and then we repeat that a few times. Each time we remove 2 from the array, and after that you get a total of 10 points. So that's kind of what this code does exactly. It's just a memoization DP approach, but it's not fast enough. So, or not fast enough. It just causes stack overflow. But yeah, so we just take an input and then we count up how many of each element there are. So for this, it would be like 0 zeros, 2 1's, 2 2's, and then, or 5 2's, and then 2 3's. And then we'd run through this function. If it's 0, return 0. If it's 1, return the first element, because there's only one element left. And then we basically check if it's in our memoized dictionary. Then we can just return that, so we don't have to recalculate everything. And then if we don't return anything in this, we can memoize that value. With this function, this is probably the crux of the problem. And you can either choose the current I value, or you can choose the one before it. If you choose the current I value, then you sum up everything before it, and you add that to count I times I. And if you don't, then you just calculate the DP for the value before it, and you take the maximum of everything. So what it would look like, I guess, is let's just take this example here. We would have uh, 0, 1, 2, 3, 0 zeros, 2 1's, 1 2 3 4 5, 5 2's, and then 2 3's. So we kind of just skip 0 because we don't look at that. This would be I times 1, so 2 times 1. This would be, or yeah, this would be, we're looking at the maximum between 2 times 1 and 2 times 5. And since it's obviously bigger, then we would pick this one. And then this one, we're looking at the maximum between basically everything before, like dp of everything before, and 3 times 2, which is 6. And I guess 2 times 5. Since this is 6, it's less than this, then we would take this output and not really look at 3. And since 1 is less, we would take 2 times 5 and not really look at any of these. So that's basically like how this question works. Oh, but yeah, as I said, I already did the implementation and I'm pretty certain it works. It's just, it's too slow. So how would we write this iteratively? Let's comment all this out. We wouldn't have this either. And I guess we would need to start, well, we would need a for loop in here somewhere, and then we would need to define like a DP array. The length of this array would be the length of count. So the length of this array, or I guess yeah, the length of count. The length of count, yes. It should be right. I don't think I need these parentheses here. And then, obviously, we can just remake these cases very simply. dp0 is equal to 0, dp1 is equal to count1. And then for I in range start stop step, we start at 2 and we end at count, and step size is 1, so don't have to worry about that. And then we have to do this step here. dp I is equal to max dp I minus 1. Well, dp is an array now instead of a function. So dp I minus 2 plus count I times I. Now this should be it, and then we would just do print dp the last value of the dp array, because that should be the greatest number. And this should be the implementation. Let's check if this works. Yep. I definitely spent way too much time on this problem, but y'all are lucky because y'all just get the last 10 minutes of me actually like doing this problem. Boredom. Okay, we got it. Now, like this was like the first DP problem, I did on here, so I was like, why not practice some DP today? Or at least like some of the easier problems, just so I can get used to. First of all, well, I learned DP like with the recursion method. Obviously, I'm not very good at writing it out as this, like iteratively. I feel like it's harder for me, and it's hard to like visualize sometimes. But yeah, also like coming up with this like equation is difficult for me too. So let's work on that today. We can do some 800s. If they feel easy, we'll move on. But um, yeah, at least we're practicing a skill this time instead of just doing normal problems like or random problems like I usually do. Hit the lottery. Rating 800. Now, I also want to stop farming these like 800 rated problems eventually when I feel comfortable enough doing like the higher rated questions. I always try to do one off camera to see like where I am, but like this definitely took way too long, and I don't want to be recording a video for 3 hours doing one problem. That'd be lame. Okay. Alan has a lot of money. He has in dollars in the bank for security reasons. He wants to withdraw it in cash. Denominations are 1, 5, 10, 20, 100. What is the minimum number of bills Alan could receive after withdrawing his entire balance? Minimum number of bills he can receive. Okay. This is his entire cash. So input equals int input. And bills. I assume we're going to need to store this. This kind of reminds me of the AIOUY question we did the other day. And so how can we DPify this? Define a DP array. But what do I do with this? Do we set DP 0 to 0? Number of bills. Is there a max length we can set this to? Or do we just need to like dot append? Okay, well, let's just define this real quick. And then I do believe this should be somewhat similar. It's like we're gonna have to work with bills somehow. Okay, how would I do this without DP? I would, well yeah, it's tagged greedy. So I would always try to force the biggest bill. Like I would have like a counter. For while balance is greater than 0. For bill and bills if okay, let's remake bills right but reversed. Comment this out. If bill and bills, if bill is greater than it is less than if if balance minus bill count, or no, if balance minus bill is greater than bill, wait, okay, this is already O(n) squared. Alright, it's two loops inside of each other. Like, this can't be right. Let me think. So what can we do? Instead of using the while loop, what were we checking earlier? If we just have this part for bill and bills, how many bills can we use? If we have 100, so let's say we have 400, like 50. We can do balance divided by bill. So we give us a fraction. So we do double divide. That will give us the number of bills. So if it's 450 divided by 4 divided by 100, we'll have 4 of that bill. So we would increment bill count plus equals count, and then balance minus equals count times bill. How do I do parentheses here? Times bill. Yeah, that seems right. And then print count. Print bill count. I think this is right. 3. I mean, this is just a greedy approach, no? How does this have to do with DP? I don't get it. This is a DP question? Here, got it. Given that, yeah, it's pretty simple to see. We can just... Okay. Yeah, I don't know. I think we need to do harder questions too. Because, how is this DP? This is just greedy. Okay, we're gonna ramp up the submission, or ramp up the difficulty. Let's do, okay, this was 1,500. Let's do like 1,200. 1,200 seems to be like the cusp of where it's like kind of hard for me. Oh, this has a lot of things. Is there... Okay, let's do this one, because some of these I don't even know, like depth first search. I need to review that before I tackle questions on that. And similar TP. Graph matchings, yeah, totally unfamiliar. I struggle with 2-pointers already, so probably not gonna do... Probably not gonna do that one. Well, let's look at this one. It's just implementation, TP and sortings, so should be something I can handle. Uh, 433B. Kuriyama Mirai's stones.py. Rating 1-200. This person has killed many monsters, got many stones. She numbers stones 1 to n. The cost of the ith stone is V. Kiriyama Mirai wants to know something about these stones, so she'll ask you 2 kinds of questions. She'll tell you the numbers L and R. She'll tell you 2 numbers L and R, and you should tell her the sum of this. Okay, so the sum of the costs between those. Okay. Let UI be the cost of the ith cheapest stone. The cost that will be on the ith place. If we arrange all the stone costs in non-decreasing order, this time she'll tell you 2 numbers, and you should tell her the sum. Okay, so what is she saying? She numbers of stones 1 to n. The cost of the ith stone is vi. She will tell you two numbers, and you should tell her the sum of the stones in between them. And let ui be the ith cheapest stone. The cost that will be on the ith place if we arrange all the stones in decreasing order. Shoot. Okay, is this just like the sum and then this is the sorted sum? For every question you give the correct answer, she'll say Fu Yukai des and become unhappy. Correct answer, she'll become unhappy. Okay? You should give the correct answer, or she'll say this and become unhappy. Okay. The first line contains in, second line contains cost of the stones, third line contains im, the number of questions, and the following contain lr, contains type and lr. Type is 1, you should output, okay. The second one. Okay. It's a holy yappa question. So, it does just feel like an implementation type question. So what was the first number? In, which is the length of the array, equals int input, and then a equals list map, list map int input dot split, and then third line contains m equals int input, then for m type lr equals map int input dot split. Make sure I put the parentheses after input. Okay, that should take in all the input now. Sum. Okay, so I'm assuming the DP in this is we can sort, or we can store like previous calculations in an array. Like we can do like memo equals this, and we can store a tuple LR as the key, then a value as the type. Alright. Okay, if let's put this outside of the loop because we don't want to reset it every time. okay, if type equals 1, do this, else do this. And so type 1 is just sum. How do we do this? Now, I feel like in order to incorporate DP, we would just check the L in the R and then add whatever. Like we would only store L. Or, huh. Like, okay, this is what I'm thinking. Let me pull out my board. Okay, I'm thinking the memo format is like something like this. But, like when you're calling it, you would do like L R, let's call this R old, plus plus V I plus I is equal to L R. So it's like R plus R old plus 1 plus V R old plus 2 all the way to V R new. Like something like that. But like what about sum? Like I can just call this function on whatever, no? Okay, I'm gonna try to do it without memo first and then see what happens. Sum of A let's just print sum A, print sum of A from L to R. Wait, what does this do? Do I need to do R minus 1? Hold on, let me just do some testing real quick. Zero, 1, 2, 3, 4, 5. So it should give me this. Okay, so it's minus 1. So it would be left to right. 1, 2, 3, 4, 6. So given this, And our left was 2, our right was 3. Just so it's right plus 1. 2, 7. Oh, minus 1. Our left minus 1. Because they start their index differently. So it'd be left minus 1. Or maybe I should just do it. No, let's just do it like this. And for this, we would do print a dot sort. Okay, sum a dot sort. And then, does this work? Okay, bunch of errors. Int is not iterable. Type. The types are wrong somewhere. In range. M. Okay. This doesn't work. 1, 2, 3. We'll just do 2, 3, like they have, but it's like 1, 1, 3. Two, 4. Okay, so I don't actually want to keep, so we need to define a separate variable. Maybe like temp is equal to sorted A, and then we run this on temp. Here we go. Let's see, 24, 9, 28. Now I wonder if this is just a straight up valid solution or if it's too slow. 10, 15, 5, 15, 5, 5, 2, 12, 3, 5. Right, let's submit it and see. Okay, cool. I'm glad that it is an actual DP. So that means we actually need this. Right. Question is, how do we do this? Like, we would need to store two, right? We would need to store the original and the sorted. So dp goes whatever, and dp sorted goes whatever. And count 0 times count. So like count is in b n plus 1. Yeah, should be n plus 1. Just do array b. Let's just call this dpa dpb. Or I can just probably do like sorted a. A sorted equals sorted a, like this. And then so I'm assuming we would just let me think. Instead of doing this, how do we, okay, we set up these arrays. If we iterate through the sum of each, so 2, 3, 4, 5, 6. These are the indexes. And then we go through the array. We can do 6, and then we can do 6 plus 4, 10, 12, dot, 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 down the line. And then so what we can do is print, oh my god, what's my handwriting? dpr, so that will grab like say we grab 5, dpr is 5, minus dp L minus 1, and that will be to the left, so let's say we grab dp2, then that would be the answer for the unsorted. Would be the answer for the sorted too, except A is sorted. Okay, I think this is right. So for in range in dp I equals dp the previous index plus index 0. Do we care about index 0? Because they don't use index 0, they start with index 1. I think we can calculate the next index, and we can ignore index 0, and then we can call the current index plus fuck the underscore. I'm sorry, Nico, but I will be sticking to index for I as index. dpi plus dp plus the array index. Right. So what does this mean? So start at 0. We're filling in dp1 is equal to 0 plus the first element of the array, which is 6. So dp1 would be 6. dp2 would be 6 plus 4. Okay, yeah, that's exactly what I want. Now, for this, it should be the same, except we would use dp sorted instead. And then we would use a sorted instead. Here. And then for underscore in range m, if type equals 1, print dpr minus dp L minus 1. Print dp sorted r minus dp sorted L minus 1. Okay, this should be it. Okay, 24, 9, 28. 10. Wait, what? Oh, this is this 10. 10, 15, 5, 5. Wait. 10, 15, 5, 15, 5, 5, 2, 12, 3, 5. 10, 15, 5, 15, 5, 5, 2, 12, 3, 5. Okay, yeah. There we go. Now what I should do is, where's this question? Okay, I don't want to go to my profile tab because it has my email, but I will go to it on my second monitor. Codeforces, profile, submissions. You boredom. Let me see if I remember how to do this. Or can I just do it from problem sets? Yes, I can. This one and boredom. Okay. Bookmark those so I review them later. But okay. I guess that's it. That's the 3 problems for today. If you enjoyed, please like and subscribe, and I'll see y'all tomorrow.